Welcome to NASA's Jet Propulsion Laboratory in Southern California. Today we are in a spacecraft assembly facility clean room, which is why everyone you'll see here is wearing protective gear and frocks like me. So, in this room, spacecraft have been built for decades, but today we've invited members of the media to the clean room to learn more about one of JPL's upcoming mission, and that's the Psyche spacecraft. It's on a mission to study a giant asteroid which is believed to be rich in metal and could give us a unique opportunity to study how planets like our own Earth may have formed. Now, it's set to launch in August, so soon Psyche is going to leave JPL and head over to NASA's Kennedy Space Center in Florida. And today we have a chance to talk to two experts. So if you have any questions you'd like to ask, use the Ask NASA hashtag or leave your questions in the comments below. And first up, we have Lindy, Elkins-Tanton, the Principal Investigator on Psyche. Thank you for joining us today.
Thank you so much. I'm very excited to talk with you.
Now, what is the first thing people should know about Psyche?
All right, why do we go to space? Humans, we can't help it. We have to explore. We've always explored our planet. Now we're exploring in space. There aren't that many kinds of worlds and places in our solar system that we've never had a picture, we've never explored. Psyche is one of them. It's a new kind of world. That's why it's so exciting to go there.
And as a principal investigator, what is your role on the mission?
I am officially the lead of the mission. But I'm a scientist, I don't know everything. My job is to make sure the science return of the mission is successful, and to try to keep the team working in the right and best direction that I possibly can, working with all the other leaders.
And now I want to know, what are you most excited about personally when it comes to Psyche?
You know, I'm very, very excited about the science. I'm hoping this is something very unusual and exciting. But beyond that, I think the reason that I'm most motivated to do this is because I think it gives this story of hope in the future for humans. There's so much that's scary in the world right now, but space exploration is a story of hope and a story of what we can do when we all work together. It's kind of a miracle. We can do this and go to space. Think of the things we can solve here on Earth.
And could you tell us a little more about the Psyche mission in general? Like, what are some of the key goals?
The Psyche asteroid, of course we named our spacecraft Psyche after the asteroid where we're going. We think it's made largely of metal. We think it could be part of the metal core of a little planet that got broken apart and stranded in the asteroid belt instead of joining up and becoming a part of Mercury, Venus, Earth, or Mars. So if it is a part of a core, it's the only way humans are ever going to see a core, because we can't go to ours. The pressure is way too much, the temperature is way too much. So it's a way of looking inside of the Earth by going to outer space.
And how does it feel to be inside this clean room right now, seeing Psyche behind you?
I've been working on this for 11 years, which is a short time in space mission terms, but it's a long time in anyone's life. And the fact that we've gone from this tiny idea to this beautiful giant spacecraft, it feels a bit like a miracle. I'm really excited.
Well, thank you so much for talking to us. Can you kind of give us a little timeline of what will happen after launch with Psyche?
Yes. So we expect and hope to launch August 1st or thereabouts. So then, once it separates from the rocket, the giant solar arrays will unfold and Psyche will start moving out toward the asteroid. In the first year, we're going to test the deep space optical communications demonstration, which is communicating with the Earth using lasers instead of radio waves. And then eventually, after 3 years, we'll reach the asteroid and we'll start doing the science of the asteroid itself.
And one thing that I think is really cool is this isn't even all of Psyche, right? There's going to be more that people will see when we have the spacecraft behind us, but there'll be the solar arrays that will be attached to it.
That's right. Our solar arrays are not attached right now. They're being tested elsewhere, but they're huge. When they're completely unfolded, as they will be in space, the spacecraft and the solar arrays are as big as a singles tennis court. And these solar arrays create 20 kilowatts of energy here at the radius of Earth.
And exactly where is the Psyche asteroid located?
The Psyche asteroid orbits in the outer main belt of the asteroid belt, meaning that it's way out past Mars, sometimes closer to Jupiter. It's very far from the Earth. That's its stable orbit out there in the asteroid belt.
Well, thank you so much, Lindy, for answering all our questions. We might come back to you if we get some more social media questions coming in.
Love
too.
it.
And if you have a question you'd like to ask, use the hashtag AskNASA or leave your questions in the comments below. Next up, we're going to go to talk to project manager Henry Stone. He's somewhere around here. Yeah, let's see where he is. There he is. Let's go find him. Hi, Henry. We are live right now, and we're hoping we could ask you a couple questions about the Psyche mission.
Yeah.
So, for you, what does it mean to be a project manager on a mission like Psyche?
A project manager on a mission like this, well, I equate it to being like an orchestra conductor, right? Building a spacecraft as incredible as this, or any system that's this sophisticated, requires an enormous number of people with a lot of different skills. And you got to bring that all together, and you got to make sure it's all coordinated, right? Everybody's developing all of their pieces at the right time, interacting together properly in order to build that. So it's just keeping everybody on the right tune to make sure that we stay on schedule, we build the right thing, and we're ready to go for launch.
And can you kind of break down the instruments on Psyche for us?
The science instruments is kind of really 3+1,
Okay.
right? So in order to get the scientific measurements we need, we have a suite. You can see them up there behind you. Up on the far boom there, we have a gamma ray neutron spectrometer that was built at the Applied Physics Laboratory. And that is going to be used to detect elemental metallic composition of the surface of Mars, looking, for the iron, nickel, aluminum, what it's made of. On this other boom here, you'll see these little domes. Those are 2 magnetometers. And they will be used to detect whether or not Psyche has a magnetic field, and if so, how strong that field is and what the characteristics and shape of that magnetic field are. And that's really key towards helping us understand whether Psyche was an early core of an early planetesimal when the solar system was formed. So that's 2 of the 3. The third of the 3 key scientific instruments actually is a pair of telescopic imagers with filter wheels. Unfortunately, in this configuration, you can't see those. They're pointing up right now at the ceiling in this room on that top side of the spacecraft, and they'll be pointing out, and they'll be used to take a map build a visual map of the entire surface of Psyche. We can understand the surface topography, understand craters, and use that to determine the relative age of the body. But perhaps most importantly is each is equipped with a filter wheel. And the filters have been chosen so that if you take images at those different light wavelengths, you can actually determine what the mineralogical composition of the surface is. So that and the gamma ray, between the metals and the silicates, we can understand how much of this is a rocky body, how much of this is a metallic body. The fourth one is gravity science. This is a very odd-shaped body, right? It's kind of like a potato, all right? And it probably will have a very unique and odd gravitational field. We can't safely go into orbit around that till we understand what that gravitational field looks like. And so our X-band telecom system that we use to communicate, to receive data from and command the spacecraft, actually does that tracking of the spacecraft. So when we start to go into orbit, at a very high orbit, that gravitational field will affect the motion of the spacecraft, and we can measure that and then determine and build the detailed model of the gravitational field. Once we have that, then we can get to successively lower and lower orbits to allow our instruments to get better and better and more refined measurements to accomplish the science. So that's the science instrument suite for Psyche.
I like the breakdown and the description of the potato. That's my favorite part.
Yep.
Now we have a question coming in on social media.
Yes.
Elias on Facebook asks, how long will it take to complete a spacecraft with planning and finishing up to completion? So the whole process.
The whole process. Well, the earliest concept for this mission was developed by the principal investigator over 10 years ago. All right? About 5 years ago, or 6 years ago or so, she had approached folks at JPL about her scientific hypotheses, and some engineers here said, hey, that's a really cool hypothesis, and we think we can develop a spacecraft that could fly the instruments you need out there. And so she began working with us, and we put in a proposal to NASA to fly this mission. And we were selected about 5 years ago. So the real, there's that kind of very early part, but once we got selected and it became serious, this is going to be a mission, fly, 5 years of development. You start with the early design and analysis, figuring out exactly what you need, who's going to provide the various pieces, etc. And then you start building. You start building up the individual components, testing those, and then you move into system integration. And this is the tail end of system integration that you're looking at. That's taking all the myriad of pieces that are necessary that were already tested at the component level and put them together to make the overall spacecraft and then test the overall spacecraft. So that's referred to as ATLO. ATLO is Assembly, Test, and Launch Operations.
Thank you.
Okay? And we're in the very final stages. The spacecraft, as you see it right here, is essentially how it will be flying in space, right? They're just buttoning it up right now. You can see all this other equipment over here is being packed up and stacked and getting ready for shipment. We're going to be shipping the spacecraft at the end of this month. On April 29th, it will be brought to March Air Force Base. It'll be in a special shipping container. It will be put on a C-17 and flown directly into Cape Canaveral. And then we will open it up, do some more testing, and get ready to start integrating it, loading it on top of the rocket that'll launch it from Cape Canaveral. And our plan is to launch in August of this year and get it on its way. From there, that's when the actual mission, so to say, starts, as opposed to just the project in the building. It's going to take us 3.5 years to fly out to Psyche. We're going to spiral out, we're going to pass Mars and get a gravity assist. We're going to use our electric propulsion engines to thrust all the way, spiral out, catch up with Psyche in its orbit. It's way on the outer edge of the main asteroid belt, which is between Mars and Jupiter. So it's way out there. 3.3 times the distance from the sun as the Earth is. So way out there. We'll take 3.5 years, and then we will spend 2 years at Psyche orbiting at successively lower and lower orbits to take the measurements I was just talking about to try and prove the hypothesis as to whether or not Psyche was the core of a very early planet formed, in the blink of an eye when the solar system was created. And that will help us to confirm whether or not our models of the formation are in fact correct. And if they're not, the thing that's really cool is then this will be an exceptionally unique and odd discovery. So no matter what happens, this is going to be a mission of discovery of what we believe is a metallic world.
It was a great answer and a great question. Thank you, Elias. We have another question coming in. Mir on Facebook asks, why not study the nearby asteroids in the asteroid belt? Why Psyche?
Well, this is in the asteroid belt. It's on the outer reaches of it, okay? But the little bit of data we have from measurements from telescopes, where it's only 4 little teeny pixels in an image, and from radar data, leads us to the conclusion at the moment that it is largely metal. Almost all the other asteroids are rocky bodies, okay? This one stands out as very unique, as having a very high concentration of metal to explain why it's so massive. It's also very large. Many of the asteroids are very, very small. This is one of the larger ones. It's basically the size of Massachusetts, right? The entire state. And that's what makes it unique, and unique in understanding the formation of the solar system.
We have 2 more questions coming in. One of them is from Kieran on Facebook. Why haven't optical communications been used till now for this?
Kieran, very good question. So obviously, Kieran, you know that we are flying the DSOC instrument, the Deep Space Optical Comm. That's actually not part of the science of this mission, but we are hosting that instrument as a technology demonstration for NASA, right? So it happens that instrument was also developed here at JPL. And the goal is to try and come up with the means to communicate with spacecraft in the future with much higher bandwidth so that we can have live videos like this from Mars. That's exactly what we're trying to show how to do that. So that instrument will be communicating with laser light as opposed to radio frequency, sending signals right back down to a telescope here in California, the Palomar telescope, where they can detect the individual photons coming from the spacecraft, and you'll be able to communicate at much higher rates. Why not more sooner than this?
Yeah.
Well, it is a really, really difficult thing to do. You were talking about really large distances to communicate, and you have to have enough energy to send a light beam down and collect it when it hits Earth, right? And that beam is going to, expand out and get lower and lower power as it gets to you. So the technology, that's a technology demonstration of how to not just detect a burst of light coming and telling you what the spacecraft is trying to say, do it down to the elemental, each individual photon is what makes that instrument so incredibly sophisticated in terms of its pointing and communication ability. So it's taken a long time to get there, and we're looking forward to that being equally successful to help all our future missions, particularly those to Mars, right? We've got human exploration coming up eventually. We'd like to have live video.
Yes, that would be wonderful to see.
Yeah.
And the final question we have is here on, it's actually Terry on Facebook. I'll kind of chime in too. Terry wants to know, what is the most anxiety-inducing part of the project, but also for you, what is the most exciting part?
Most anxiety part, I guess, is just missions like this. You can't just launch anytime you want. You can't launch when you're ready, so to say. You have to, it's planetary. You've got to go at a specific launch window. You can't move that around. It's a really hard date. And these are incredibly complex and sophisticated, robotic explorers. The stress of trying to make sure that you get it all done and tested and it's ready to go on that fixed date is probably the most anxiety ridden one. And the second part of the question, I'm sorry, was the
most exciting part for you.
The most exciting part?
Yeah.
Well, it's kind of twofold. It's the science, right? And going to explore this body that no one's ever been to before, right? The second part for me as an engineer, really, is having the opportunity to work with a fabulous team of people, specialists in all different areas, and to orchestrate that in order to build these incredibly complicated and sophisticated pieces of equipment. That, as an engineer, just floats my boat.
Well, this is very exciting. Thank you so much for talking to us today. And there's lots of members of the media coming in right now to have questions for you as well. So I'll let you get to that. And
Great. Thank you very much.
Thank you. Now, Psyche is set to launch in August from Cape Canaveral, Florida. Now, to learn more about the mission, follow at NASA JPL and at NASA Solar System, and also follow the hashtag Mission to Psyche. Thanks for watching.